Hello, Matt Davis here with more homework quiz help. This one comes from section 9.2. In April 2010, the Gallup organization reported that 76% of Europeans stated that they were satisfied with the quality of the air in the city where they live. At the same time, a sample of 1,015 people living in the Americas, North and South combined, contained 739 people that were satisfied with the air quality in the city where they live. We wish to conduct a hypothesis test to determine if the true percentage of those in the Americas that are satisfied with their air quality is lower than in Europe. Calculate the value of the test statistic around your answer to 3 decimal places. All right, so even though in this one they're specifically asking us to calculate the value of the test stat, it's hard for me to show you that without doing the steps before, and people often have trouble with the steps after, so we're specifically in this setting for test stat, but we're going to do the steps before and after and discuss those as we go through. But first, some changes in the interest of giving help rather than answers. So I'm going to make some changes to this one. Instead of having it be 76% of Europeans, we're going to pretend that number was 75% and do our work that way. And then in our sample, instead of it being 739 people, we're going to have that be 727. All right, so with those changes, let's go ahead and jump in. First step in a hypothesis test is to come up with the null and alternative hypotheses that we're going to be working with. And the first step in that process is to determine if you're in mean land or proportion land. So jumping in there, we see a key word here that we're doing a test about the true percentage of those in the Americas. So that means our claim is going to be about P equals and an alternative about P as well. So for the P equals piece, we want to see what was the claimed value or the old value or the value we're comparing to. In this case, we're comparing the Americas to Europe. So the comparable value is that 0.75 up there. So that's what we're going to use. I said 0.75. Of course, it says 75% there, but we need to change that to decimal form when we switch to our hypotheses and write it in terms of P. And then for the alternative, we need to see whether we're doing a left-tailed, right-tailed, or two-tailed test. And we're trying to see if the air quality or the true percentage of those in the America that are satisfied with their air quality is lower than in Europe. So because of that lower than, we're going to say the alternative is that the value in the Americas is lower than it is in Europe. Next step would be to write down our significance level in decimal form, but they didn't list the significance level here, so I can't really fill that in. We'll have to kind of just talk about that for various alphas when we get down to step 5. But we can work on step 3 and 4 without that. So let's jump in there. The first thing you should do when you're doing step 3 is to write down your formula. Because we're in proportion setting for this hypothesis test, we're going to be looking at a z-score. And the z-score would be p hat minus the claim value of p, p0, divided by the square root of p0 times q0 over n. So that's what we're going to be working with. And the key piece that we need to calculate first is the p hat. So we'll take a moment to go ahead and do that. So p hat is x over n, where x is the number of successes in our sample and n is the sample size. In this case, what we were looking for was people who were satisfied with their air quality. So we had 1,015 for our sample size, and we had 727 of those that were satisfied. So that 727 is our x, and this 1,015 is our n. So we're going to use those for p hat. So p hat is 727 divided by 1,015. And we can go to the calculator and do that division. And when we round it to 4 decimal places, we get 0.7163. So there's our sample proportion p hat. And now we can get to work on the full test statistic. So z is equal to p hat, that's 0.7163 that we just calculated, and then minus p0, where p0 is the value that was claimed in h0. There's our h0, so p0 is 0.75. And then very important when you go down to the denominator to notice that that p0 carries over into the denominator, not the p hat, but the p0. So when we do our square root in the denominator, we don't put the 0.7163, but the 0.75. When we do 1 minus, it's always 1 minus the number we put right here. So 1 minus 75% would be 25% or 0.25. and then divided by the sample size, which is 1,015. Whatever we get there, rounded to 3 decimals, would be our test statistic, which, by the way, is what they want us to find. So when we get this, we'd have the answer to this specific question, but we'll keep going, talk about the p-value and the decision as well. All right, so moving over to the calculator, let's see what we get for that. We need parentheses around the top, so 0.7163 minus the claim value, 0.75, in the parentheses, so that subtraction gets done before the division. And then in the denominator, we want a square root. I started an open parenthesis there, but we don't want that before the root. We want it afterwards, and the calculator starts that for me automatically. So we have our P0 times Q0. Don't close the parentheses yet, because part of that square root is dividing by the sample size, so we need to get that in there before we close the parentheses. So parentheses around the numerator, parentheses around the stuff in the square root. All right, rounding this test statistic to 3 decimal places would be negative 2.479, sticking with the 9 because it's followed by a 4. So bringing that back over here, we have negative 2.479. And because this problem asks for the test stat, that is the part we'd put into our active learning answer box, but we will continue on here. So the next step would be to calculate the p-value. This is a z variable, so we're going to draw the z curve, put 0 in the middle to represent the claimed proportion, and then negative 2.479 is way over here on the left. And then to decide whether we shade the left or the right isn't based on whether this value was on the left or the right. It's based on what we see right here in H1. That less than means it's a left-tailed test. So we're going to shade the area to the left-hand side. And on a one-tailed test, that area we end up shading is our p-value. So how do we get that p-value? Well, it's a z-score, so we're going to use normal CDF. Our left-hand boundary is way over there, which would be negative infinity. Our right-hand boundary is right here. So negative 2.479. And then we'll go to the calculator and see what we get for that, and whatever we get will be our p-value. So second distribution menu, normal CDF, left boundary, negative alpha infinity stored in the I, and then right boundary, negative 2.479. Rounding this p-value to 4 decimal places, we would get 0.0066, rounding the 5 up because of the 8 that follows it. So p-value 0.066. I missed a 0 there. Let me go back. 0.066. So there's our p-value. That's the risk we'd be taking of making a type 1 error if we decided to reject HO with our current evidence. That looks like a pretty low risk. As long as that risk is smaller than alpha, we would reject HO. Our standard alphas tend to be 1%, 5%, or 10%, and this is less than any of those, this p-value. So because our p-value is less than any of the standard alphas, we would reject HO this time. Again, whether we do that or not does depend on the specific value of alpha, which I don't have written down on this problem, but the standard ones are 1, 5, and 10%. So for any of those, our p-value would be smaller, and we would reject. All right, so quick review of places where this can go wrong for people. When you're doing your test stat, remember parentheses around the top. When the calculator opens the parentheses for the square root, don't close them until you get all 3 numbers in there. Make sure that you're not using the p hat in the square root, but the claim value p0. Make sure when you subtract, you do 1 minus the number in the front, the 0.75, not the p hat. Other things, this is a left-tailed test, so make sure that you remember to use a negative infinity. When you go to normal CDF, make sure you put that as your left boundary, not your right boundary. Other things, sometimes people get in the habit of doubling the area when they do a normal CDF, but that's only for 2-tailed tests. This is a 1-tailed test. By the way, in terms of messing up the infinity or getting these boundaries right here in the wrong order, one way you can catch that is to think about, does this answer you got for your p-value make sense? We got a very small answer. Notice we had a very small amount of area shaded, so kind of checking on that can help you catch some calculator areas or errors as well. All right, and then of course there is a step 6 too, but we'll skip that one. That didn't end up being a trouble spot for too many people when I looked through the old quizzes. All right, hopefully somewhere in there you saw the spot that was giving you trouble. Good luck to you as you head back to the quiz.